This section describes using IAM for authorization. When you grant permissions, follow the standard security advice of strong authentication and the principle of least privilege. In practice, this means granting only the permissions needed to perform a task. It's more secure to start with a minimum set of permissions and grant additional permissions as needed. This provides better security than starting with permissions that are too permissive and trying to restrict them later. Define the correct permissions by assessing what access is needed to accomplish a specific task. Determine what your users need to do, and then craft policies that allow them to perform only those tasks. Similarly, create policies for individual resources that identify precisely who is allowed to access the resource and allow only the minimal permission for those users. IAM policies can grant or deny permissions. In this example, the users in the IAM group can read, write, and delete objects in bucket 1. However, they can only read the objects in bucket 2. By default, an IAM user, group, or role can't access anything in your account until you grant them permissions by creating a policy. Most policies are defined and stored in JavaScript Object Notation or JSON documents. Policies define the effect, actions, resources, and optional conditions under which an entity can invoke API operations to the AWS account. Any actions or resources that aren't explicitly allowed are denied. When an IAM principal makes a request, AWS evaluates that request based on the permissions in these policies to determine whether to allow or deny access. AWS currently supports 6 types of policies. Let's take a look at each. Identity-based policies are attached to IAM identities to grant permissions to the identity. Resource-based policies are attached to resources and grant permissions to a specified principal. Identity-based and resource-based policies are the only 2 policy types that can be used to grant permissions. Permissions boundaries define the maximum permissions that identity-based policies can grant to an entity. AWS currently supports 6 types of policies. Let's take a look at each. Identity-based policies are attached to IAM identities to grant permissions to the identity. Resource-based policies are attached to resources and grant permissions to a specified principal. Identity-based and resource-based policies are the only 2 policy types that can be used to grant permissions. Permissions boundaries define the maximum permissions that identity-based policies can grant to an entity. Permissions boundaries can't grant permissions. An AWS Organization Service Control Policy, also known as an SCP, can define the maximum permissions for account members of an organization or an organizational unit, or OU. You can use SCPs to limit the permissions of identity-based or resource-based policies, but they can't be used to grant permissions. Access control lists, or ACLs, can be used to control which principals in other accounts can access the resource the ACL is attached to. You can't use an ACL to control access for entities that reside within the same account. Finally, session policies are used with the AWS CLI or API to create a temporary session for a role or federated user. You can use session policies to limit the permissions that an identity-based policy grants to a session. Session policies limit permissions but can't grant them. The difference between identity-based and resource-based policies is where they're applied, which depends on the type of access that you're authorizing or restricting. Identity-based policies are attached to an IAM user, group, or role and indicate what that identity can do. For example, you could grant a user the ability to access an Amazon DynamoDB table. Resource-based policies are attached to a resource. They indicate what a specified user or group of users is permitted to do with the resource. For example, you could grant access to an S3 bucket or grant cross-account access between 2 trusted AWS accounts. IAM policies can be managed or inline. Managed policies are standalone, identity-based policies that you can attach to multiple users, groups, and roles. AWS creates and manages AWS managed policies, and you can create and manage customer managed policies. Managed policies provide features such as reusability, central change management, versioning and rollback, and the ability to delegate permissions management to other users. Managed policies also provide the use of permissions boundaries. This is an advanced feature that allows a managed policy to set the maximum permissions that an identity-based policy can grant to an IAM entity. Inline policies are embedded in a principal entity, meaning the policy is an inherent part of the entity. You can use the same policy for multiple entities, but those entities don't share the policy. Instead, each entity has its own copy of the policy, meaning it's impossible to centrally manage inline policies. Inline policies are useful to maintain a strict one-to-one relationship between a policy and the principal entity it's applied to. This is because inline policies cannot be inadvertently attached to the wrong entity. Use cases will vary, and you should select policies based on the situation. In most cases, AWS recommends using managed policies instead of inline policies. This diagram shows the logic that AWS uses when evaluating IAM policies. By default, all requests are denied. An explicit allow overrides the default deny. An explicit deny overrides any explicit allow. The order that the policies are evaluated in doesn't have an effect on the outcome. All policies are evaluated, and the result is always that the request is either allowed or denied. Suppose that a conflict occurs. One policy allows an action and another denies an action. The most restrictive policy, that is, the policy that denies the action, is applied. Here are the key takeaways for this section of the module. Permissions to access AWS account services and resources are defined in IAM policy documents. Attach IAM policies to IAM users, IAM groups, or IAM roles. Follow the principle of least privilege when you grant account access. And finally, when IAM determines permissions, an explicit deny will always override any allow statement. That's it for this video. Thanks for watching. This section provides examples of how IAM is used for authorization. After you apply an identity-based policy to a principal, the policy allows or denies the entity the ability to perform specified actions. In the examples shown, if the entity is a user, the policy allows the user to create, delete, get, or update their own password by using IAM login profile actions. The user can also perform actions on their own access key by using IAM access key actions and on their own secure shell or SSH keys by using IAM SSH public key actions. The actions in the policy include wildcards as indicated with an asterisk. Wildcards provide a convenient way to include a set of related actions. Notice that the policy gets the AWS username dynamically as defined in the resource key. This example shows a resource-based policy that allows some cross-account access. In this scenario, account A created a resource-based policy. The policy grants account B access to perform any Amazon S3 API operation, as indicated by the asterisk, on account A's S3 bucket named doc example bucket. This S3 bucket policy doesn't specify any IAM principles. Instead, it specifies account B by the account number. Account B should create an IAM user policy to allow a user in account B to access account A's bucket. To understand how IAM policy logic works, consider this example. The first half of this policy is an explicit allow that gives users access to only specific resources, a DynamoDB table named Course Notes, an S3 bucket named Course Notes Web, and an S3 bucket named Course Notes MP3, including all of its objects. The second half of this policy is an explicit deny. This explicit deny ensures that the entity can't perform any action on any DynamoDB table or S3 bucket except those specified in the policy statement. Even if permissions are granted in another policy, the explicit deny will override them. Remember that an explicit deny takes precedence over an allow. In its totality, this IAM policy allows access to specific DynamoDB and Amazon S3 resources and explicitly denies access to any other DynamoDB or S3 resources in the account. Let's look at how a permissions boundary policy works. Assume policy 1 is attached to IAM user example user. This policy allows the user to manage only Amazon S3, Amazon CloudWatch, and Amazon EC2 resources, and restricts all other services, including IAM. If IAM policy 2 is then attached to example user, and they attempt to perform the IAM create user operation, the operation fails. This is because of the restrictions placed by policy 1. That's it for this video. Thanks for watching.
Welcome. In this video, I'll show you how to configure cross-account access so that resources in one AWS account can be accessed from another AWS account. This diagram shows what I'll accomplish in this demonstration. First, I will create a resource that I want the other account to be able to access. In this example, the resource is an Amazon Simple Storage Service or Amazon S3 bucket with an object in it. Next, I'll define an AWS Identity and Access Management or IAM policy and an IAM role to attach the policy to. Then, in the other account, I'll define an inline IAM policy that allows the user to assume the role I defined in the first account. This will allow the user to access the S3 bucket. Okay, let's get started. In this browser, I am logged into the production account. Notice that the upper right corner of the AWS Management Console window shows who I'm logged in as. It also shows the account number of the AWS account that I'm authenticated to. So I'll first create a resource, in this case an S3 bucket. Notice I'm keeping public access blocked. I will accept all the default settings and create the bucket. Now, I'll add an object to the bucket. I'll just add a simple image file. I'm going to copy the bucket name because I'll need it in a moment. I'm going to create a second bucket as well. I want 2 buckets in the account so that later, when I grant access to one bucket, I can show that I'm not granting access to all of the buckets in this account. Next, I'll load the IAM console and create an IAM policy. The policy should grant access to all actions in Amazon S3. However, under Resources, I want to indicate a specific bucket. I choose Add ARN, and now I'll paste in the bucket name that I just copied a moment ago. This will grant access to the bucket, but I also want to allow access to the objects in the bucket. To do that, I'll choose Add ARN, and for the same bucket, I'll choose Any for the object name. Based on the input I provided, the wizard has built a JSON formatted policy document. The policy has 2 statements. In the first statement, the SID, which means statement ID, name value pair, has the value visual editor 0. This is an optional identifier. If you use one, it must be unique within the policy. Next, the effect is set to allow. Then, the policy has a list of specific S3 actions that this policy will allow. Finally, the policy allows the listed actions on any resource in the account, which is indicated by the asterisk. The second statement allows all S3 actions. However, it only allows them on 2 specific resources. The first resource is the bucket that I just created, and the second resource allows actions on any object in that bucket. I don't need any tags, but I do need to give this policy a name. I'll name it Cross-Account Access to S3 Bucket, and go ahead and create the policy. Great! Now I have an IAM policy. To use the policy, I need to associate it with an IAM principal, such as a role, user, or group. With the cross-account access objective in mind, I'll create an IAM role and attach the policy to that. After choosing Create Role, I need to specify the trusted entity. In this case, it's another AWS account. I need to know the account ID of the other account, the developer account. It just so happens that I'm already logged into that account. I'll copy the account ID, then paste it back here in the IAM role settings. Next, I'll attach the policy I just created. I can search for that policy. It was called Cross-Account Access to S3 Bucket. There it is. I don't need to add a tag, but I do need to give this role a name. I'm going to call it Access to S3 Bucket from Dev Account, and then create it. Great, I'm making progress. I'm going to copy the new role's ARN because I'll need to use it in just a moment. I'm also going to copy the link that says Link to switch roles in console. So far, everything I've configured has been in the production account. The production account trusts the development account to have access to a particular S3 bucket that exists in the production account. I did this by creating an IAM policy and attaching that to an IAM role in the production account. The role identifies the development account as a trusted principal. In the IAM policy, I also define the actions that users who switch to the Access to S3 bucket from Dev Account role will be able to do. Okay, now I'm logged into the development account. I have not used this account in the demo other than to copy the account ID earlier. This development account has a user named AWS student who will try to access the S3 bucket that I created in the production account. So, what do I need to configure in this account? First, I need to create an IAM policy to allow the user to assume the role that I already defined in the other account. I'm going to use an inline policy, which means that it's added directly on the IAM user resource. I'll paste the JSON policy in here. This policy has an allow statement that allows the user to assume an IAM role. STS stands for the AWS Security Token Service, also called AWS STS. With this service, you can request temporary limited privilege credentials. Notice that the resource in this policy is the IAM role that I defined in the production AWS account. I need to replace prod-account-ID with the actual account ID. I'll paste the account ID into the policy details. I'm going to name the policy Access to S3 Bucket and Prod Account and create it. Now, I want to look at the Security Credentials tab. Notice the console sign-in link. I'll copy the URL so that I can test it. Now I'm ready to test the configuration. I need to log in as the AWS student IAM user, which is defined in the development account. I'll copy the console sign-in link into a new browser session. And I'll enter AWS student as the username and enter the password as well. Now I'm logged in as the AWS student user, and I can see that at the top of the screen. Next, I'll open the Amazon S3 console. Notice that there are no buckets. This is expected. That's because the AWS student user is logged into the development account. Remember, the S3 bucket that I want this user to be able to access exists in the production account. To see the bucket, I need to assume the role I created earlier in the production account. To assume the role, I choose the drop-down menu in the top right of the screen that shows who I'm logged in as, and select Switch Roles. Now, I'm prompted to enter the account number and the role name. I've copied the production account number, which I will paste in here. The role name was access to S3 bucket from dev account, so I'll fill that in as well. The display name is optional, but I'll set that to dev account user. Finally, I'll choose switch role. So now I've assumed the role. Notice the red label at the top of the console shows the account number I'm now connected to. And look at that. I can see the bucket that exists in the production account. I'm logged into the development account, but I can access a resource from the production account because I've temporarily assumed a role that allows the access. Let's see if I can access the image file in that bucket. Yes, and I'm able to access it and download it. Returning to the bucket list, notice the bucket in prod account no access bucket. The access column shows error. If I try to view the contents of this bucket, I see an insufficient permissions to list objects error. This is expected because of the permissions I granted in the IAM policy that's attached to the IAM role that I have assumed. Okay, I'm the AWS student user and I'm finished accessing the S3 bucket in the production account. I want to resume my regular access to resources in the development account. I choose the drop-down menu here and choose Switch Back. The account number displayed at the top is now again the dev account number. And when I go back to look at the buckets, no buckets display. This is because no buckets are defined in the development account. In summary, you have seen how to grant permissions to access resources created in one AWS account to use in another AWS account. You have also seen how a user in another account is able to switch roles and gain access to those resources. Thanks for watching this demonstration.
It's now time to review the module and wrap up with a practice certification exam question. You should now be able to authorize access to AWS services by using AWS Identity and Access Management, or IAM, users, groups, and roles, and differentiate between different types of security credentials in IAM. You should also be able to authorize access to AWS services by using identity-based and resource-based policies. Identify other AWS services that provide authentication and access management services, and centrally manage and enforce policies for multiple AWS accounts. Now let's look at a sample exam question. How would a system administrator add an additional layer of login security to protect a user's access to the AWS Management Console? A, use Amazon Cloud Directory. B, audit AWS Identity and Access Management, or IAM roles. C, activate multi-factor authentication, or MFA. Or D, enable AWS CloudTrail. Note the key requirement stated in the problem. The keywords to focus on are additional layer of login security. Consider the answer choices and rule them out based on these key requirements. We'll pause a few seconds before discussing the correct answer. So how do these answer choices compare to the requirement? For the first choice, using Cloud Directory would help you to build flexible cloud-native directories, but it wouldn't add any additional layers of login security. Looking at the second choice, an audit of IAM roles would show you the IAM users that currently have roles assigned, but this won't add any additional security. The third choice, activate MFA, would add an extra layer of protection on top of a username and password. This is likely the answer. The fourth choice, by enabling CloudTrail, you could log the date, time, and identity of users accessing your directory data. However, this wouldn't provide additional login security. Let's see what the correct answer is. The correct answer is C. With MFA activated, when a user signs into the console, they'll be prompted for their username and password, which is the first factor, what they know. They'll also be prompted for an authentication code from their MFA device, which is the second factor, what they have. MFA provides increased security for AWS account settings and resources. That concludes this module. Thanks for watching.
Welcome to the Securing Your Infrastructure module. This first section provides an introduction to the module. At the end of this module, you should be able to define the components of a virtual private cloud, or VPC, recognize account boundaries, and describe AWS services that are available to protect your network and resources. This module is broken into sections, each with its own video. Let's discuss how the concepts in this module are applicable to the bank business scenario. After Maria's last meeting with John, she realized that John's security concerns go beyond user access and management. To make her case for AWS migration, Maria would need to assuage John's concerns by helping him understand how the bank's infrastructure can be properly secured in AWS. John asked Maria how they would ensure the security of the infrastructure that any bank could potentially migrate into AWS. For the next meeting, Maria decides to focus on using a VPC and applying multiple layers of security to support the network infrastructure. This module focuses on the operating system, network and firewall configuration portion, and the network traffic protection portion of the shared responsibility model, which the customer is responsible to secure. Thanks for watching. This section describes the structure of a three-tier web application. A three-tier architecture is a software architecture pattern where the application has three logical tiers: the presentation layer, the business logic layer, and the data storage layer. This architecture is used in a client-server application, such as a web application, that has a front end, a back end, and a database. Each layer or tier performs a specific task and can be managed independently of each other. This represents a shift from the monolithic way of building an application where the front end, back end, and database are all in one place. Thanks for watching. This section provides information about using a VPC as part of securing your infrastructure. Use the Amazon Virtual Private Cloud Service, also known as Amazon VPC, to provision a logically isolated section of the AWS cloud where you can launch your AWS resources. This isolated section is called a Virtual Private Cloud, or VPC. Amazon VPC provides control over your virtual networking resources, such as selecting your own IP address range, creating subnets, and configuring route tables and network gateways. You can customize the network configuration for your VPC. For example, you can create a public subnet for your web service that can access the public internet. You can place your backend systems, such as databases or application servers, in a private subnet without public internet access. Finally, you can use multiple layers of security in a VPC to help control access to Amazon Elastic Compute Cloud, or Amazon EC2, instances in the VPC subnets. Security mechanisms include security groups and network access control lists, or ACLs. A VPC is a virtual network that's logically isolated from other virtual networks in the AWS cloud. A VPC is dedicated to your account, belongs to a single AWS region, and can span multiple availability zones. After you create a VPC, you can divide it into one or more subnets. A subnet is a range of IP addresses that divide a VPC. Subnets belong to a single availability zone, but you can create subnets in different availability zones for high availability. Subnets are generally classified as public or private. Thanks for watching.